All right, welcome to game engine stream number 7, AI stream number 4. All right, let me just get set up and make sure everything is working. I think I have everything. Okay, let's see. Let's go ahead and start. Give any updates. Okay, yeah. So I have one update that's relevant for this stream. So basically, if you saw my last stream, you'll note that or if you saw my engine, you'll see that I committed some code off stream. I'll show you what I committed. It's real quick. It's nothing crazy. And then if you're watching this on YouTube, I will have a link to the commit that I made prior to the stream, as well as the commits that I do in this stream in the description. Right, so you can take a look at both. But really the commit just boils down to I renamed a few things and that's it. I didn't change any functionality. I didn't change any like actual like functions or anything. I just changed like the naming of something and that was it. So I figured I can get away with doing that off stream. But yeah, I think that's it for updates. Let me go ahead and make this cat small and we can go ahead and start for today. And I'm actually pretty excited for today because this is the first day that I'm actually able to make some like real progress on the AI system. I mean, we've been doing some stuff so far, but today is the day where we actually start like putting things together. So I think it'll be good. Let's put that back. Let's go take a look at the progress board. Wherever I put it. Here. Okay. There we go. So last time, right? Last time I pretty much finished adding the UI for all of the data elements of the AI system. So if we take a look at the diagram that I have, basically in the past few streams, all we've been doing is just setting up the data for this, how do I say, for the system, right? We have already made sure that all function stubs are available. We know what we need to do for each function, right? And all of this data is available. We can edit the data. Editing the data is available in the editor, right? So you can go ahead and create an AI state. You can create a UI AI component inside of an entity. You can create different message types. And yeah, like, so pretty much everything's pretty much set up. And right now we're just gonna like start actually coding the system. So yeah, I'm pretty excited. And okay, let's also so the change I made in the previous commit again was renaming things. I just renamed the AI message types to just message types. So I took out this AI part. I took out hold on, sorry. Yeah, I took out like this AI for like, no, not AI message. No, yeah. I took out the AI and AI message. So now it's just message. And that's it. And then you'll be able to see in the scripting system that that's reflected there as well. So I think that it looks a lot better, in my humble opinion. So I think today we're really just going to just run down this list and just start adding in the code. And then once the code's in, we can go ahead and just test it out, see if it's functioning, see if it's working. And then the last thing is just hooking it up basically into the editor so that we can call these functions at runtime. And then that'll be it. The AI system, as far as system goes, will be done. And then I'll go ahead and hook it up into Pong after, so that'll be a different stream. And we can see if it actually works in the video game, so that'll be cool. So let me go ahead and update the progress board. Let's see. So connect AI service functions to scripting system, and then get AI functions working. So this probably will go first, right? So we'll go ahead and do this. Let me break this down into like some smaller chunks. So we're going to get AI service functions working. So get init / terminate lifecycle functions working. Let's see what next makes sense to do. Yeah, make sure unupdate's working. Make sure we can change the states, revert the states. Well, I guess we'll just go down the list. So handle all other functions. Pretty simple. So yeah, let's go ahead and get started. Go ahead and open up the project and take a look. I think I'm connected. Okay, there we go. Yeah, all right. So let's go take a look at AIService, our actual system, right? So again, I said init and terminate, right? So let's go ahead and get init terminate working. Initialize AI context. So this is pretty easy. The main thing for AI context is just making it a thing. So S context, or maybe it's S AI context. Yeah, AI context. We'll say if not SAI context, then we'll go ahead and create an AI context. SAI context is equal to create ref. So we'll make a shared pointer. Oh, and then by the way, the create ref is just a macro wrapping a shared pointer. If anyone was wondering what I was doing with that one. So ref here is just a template type alias, or an alias over shared pointer. So we want actually, hold on, I need some water. My voice is messed up. Oh, BRB. All right, I am back. Let's see. Let me just fix something with OBS really quick. Yeah, I don't know why this doesn't pop up. Okay, there we go. I guess it was bugged last time. That wasn't working. All right, cool. Okay, so what we're doing, so we want to initialize the AI context, right? So we check if it's currently initialized. If it's not initialized, we go ahead and initialize it. So we do AI context, right? And then we just create ref. And then we want to go ahead and initialize its data variables, right? So we'll do AI context. Let's see what we need to initialize. I believe all message types is like value initialized, so we should be fine there. Or not message types, all messages, right? Because it's basically, actually, maybe I should rename that. Maybe I'll call it message queue. Message queue. It's basically just holds all of the delayed messages in order, right? But yeah, we don't need to initialize or anything. This is already like initialized in the constructor like this, right? So we're fine. However, we do want to initialize the all message types for sure. So let's do all message types dot. How do I say? We want to fill it. So we're gonna first thing we're gonna do. First thing we're gonna do is make sure that our project. Actually, yeah, we should actually include projects as well. So let's do hash include Cardano project.h. Yeah, okay. So then project's namespace, project service, and we're gonna go ahead and get the active project. So s active, or no, maybe it's a function. Yeah, get active. There we go. So let's go ahead and assert, because if we're calling init, there should be a project available. If there's not, there's something I messed up. So let's go ahead and assert that. And then after we assert that, we want to use it to fill the data. Right, so basically the idea is, and let me go and put this in a comment, and actually I'll put this alongside here. Fill message types with values specified in project definition, in project, in active project. So basically the idea is we're probably gonna do a for loop, and then we're gonna do a for loop through, if I recall, I think it's project service gets message types, all message types, I think. Yeah, there we go. Yeah, so this is gonna return a I believe a vector of strings. And then let's go ahead and be clear about this. It's going to be const. I don't intend on editing it here. So let's go ahead and be clear about that. And then it's going to be message name, right? So this is just a string. I believe. Let's make sure. Yeah, there we go. So it's vector strings. And then now for each one, the string is basically, it's, how do I say? Dynamic. It's a dynamic piece of heap memory, right? That needs to be queried at runtime, which would be horrible for like performance. I mean, not horrible, but you know, you'd be surprised how bad string operations can mess you up in your program. So we're going to turn each string into an integer. We're going to hash it and turn it into an integer, and then using that integer, we're going to use that integer to make comparisons to check at runtime whether, how do you say, whether that message is a valid type, or like what type it is, right? So what we're going to do, and let me make sure what type this is. I think it's a set. Yeah, it's a set. So we're just going to go ahead and insert it. So for each one, we're going to do SAI context. We're going to actually convert all message types, yeah, dot insert. And I don't know if insert provides an API for like if it provides a boolean or something, or like lets me know like if it's an invalid value. Maybe I should check that. But basically what I want to insert it, and then I want to see if the insertion was successful or if I had to overwrite something. Because if I had to overwrite something, that means that there was a collision, and this unordered set doesn't handle collisions well, I think. Yeah, it doesn't handle. Or is it a hash? Okay, I know an unordered map is a hash table. I don't know how an unordered set is set up specifically, but I'm assuming it still uses a key. I'm just thinking in the case where yeah. Okay, so if you have two identical keys, like say you have two strings that are different, but somehow they somehow, I don't know, out of like the 4 billion options that are available in a uint32_t, you end up with a collision. I should be notified of that as like the engine programmer. I should be notified of that. So let me see if insert returns some like information that I can use. Let me see, unordered sets dot inserts. Yeah, here we go. What do you do function? So it returns a pair, it looks like. So I provided the const value type reference value, sure, or you provide our value, sure. Talking about these two. And then it returns an iterator and a bool. So parameters and then return value. Verse 1.2 that returns a pair object which whose first element is an iterator pointing either to the newly inserted elements in the container, like I'm assuming if you want to like do some extra processing, and a bool indicating whether the element was successfully inserted or not. Do they have something describing the behavior of it if there is a collision? The parameters determine each element only if if it is not equivalent to any other element already in the container. So that would be the false case. If you try and insert like a particular key in and the key is identical to another key, then it will fail, which is what I want to know about. So that's fine. So what I can do is just go ahead and get back that key. Well, let's go ahead and put in the input first. So it's going to be, I think I need file, right, .file system. If you recall from the last section that I did, I used my utility file system, and in here I have like a CRC hashing function. So I'm going to go ahead and use that to hash the string into a uint. So let's go ahead and do that. Utility file system, and I think it's CRC. CRC stands for cyclic redundancy check, by the way, if anyone's curious. And they use it, I think, in networking a lot, and there's other like other different applications and whatnot. CRC string, that's what we want. So we're going to do message name. And basically you can see that it's going to run this hash, and it's going to input a string and output a uint32t. So that's what gets inserted into here, which if we look at the type of the set, it is a uint32_t. So everything's kosher here. And then we want to get back that iterator and then boolean. So I think I just have to do like an auto. An iterator is usually a pretty simple value, so I can just do iterator and then success. And I don't care about the iterator. I just want to know if this was successful or not. So I'm gonna kg assert that success like happened, right? And if it didn't work, then I should know about that immediately, because that's like a design issue. I need to fix this if that happens, but I don't think so. I think it should be fine as far as I can tell, because it's you just have like a certain number of how do you say, message types that you add in as a designer, right? And it doesn't allow you to provide like an identical string. And GUI does like a similar system where like you provide a string as a name, and then at compile time, GUI takes that string and hashes it into an integer that can be used to uniquely identify that widget, right? And it seems like it works as far as I can see. So yeah, should be fine. So it looks like this should work. I don't think there's anything else I need to do to initialize the AI context. This seems fine. So, and actually, yeah, this is this is literally this. Yeah. So maybe I can, I don't know, do this. Let's say from active project. There we go. Yeah, don't need to comment everything. And the last thing, I have like an API for verifying whether initialization occurred on a pointer. So I'm gonna do, I think it's kg verify. And then we're just going to verify that AI context is valid. And then this will pop up in my console. I forget if I usually put a comment or something. See if I can find that. KG verify. See an example of this somewhere else. Okay, yeah, so I just put like a little message here with that, so load the control F function, let's see. Okay, where was I at? AIService. We were in Init. Okay, yeah, so something like this. So I'll say AI service system initiated. Perfect. Cool. Okay, so I think Init's done. We might want to call it. Well, let me finish Terminate really quick. So this is essentially the same thing. We're just going to verify that it's not a thing now, and we need to make it not a thing. So we're going to do SAI context not reset, and then just to be extra verbose, I'm just going to do this. That should clear it. And now we just need to figure out where we start this AI service and where we end it. So I need to do that for both the editor and the runtime. The server doesn't need it. It doesn't use AI inside of the, and maybe at some point it will, but for now it doesn't. Let's head over to the editor app. I believe the relevant code, yeah, just exists in the editor app. So like plainly no, doesn't exist in like a panel or something. Yeah, here we go. So in the editor app Init, we have all these things that are initializing. We want to make sure that we initialize the project after, I mean, we want to make sure that we initialize the AI system after we open the project, since it uses the project's information. I'm wondering, rendering has nothing to do with rendering, font has nothing to do with fonts, runtime UI has nothing to do with runtime UI. I don't think the panels have anything to do with it. UI service, okay, so I think right here is as good of a spot as any. So instead of, there you are, do AI service init. And I think this is defined in my header file. I have oh wait, let me go up here. Wait, do I not define Corona? Oh no, this is the project panel. What am I doing? No. Here. How did I end up in? Okay, whatever. Corona.h. Let me make sure it's defined somewhere. It is. Cool. Yeah. So yeah, that should work. And then we want to call init at the terminate at the right time. So has nothing to do with editor UI. Has nothing to do with audio. It does have something to do with scripting. So that's interesting. But thing is, like yeah, actually, well, there are scripts that are used in the AI service, but they're not particularly how do you say? They're not tied to the service itself. So what I mean by that, I can look at the diagram and kind of like show you that. So basically, like you can see the AI service, it contains its AI context. This is the main thing that's being managed in the Init and Terminate for this AI service, right? And you can see it's just a map of the messages and then like this type. This has nothing to do with like anything else, like any other system. It just gets initialized. I mean, other than being initialized by the project, if you terminate, it doesn't like have any weird dependency issues when you close it. So like these ones use like dates and these things and whatnot, but yeah, closing it in any like other weird order shouldn't mess it up. So I'll just put it behind scripting just to be safe, but I don't think it would matter either way. And then I just need to make sure that in the runtime app, you know, when we're actually using the game, playing the game, we want to make sure we initialize it and terminate it as well. So no, those are wrong. Wait, what am I doing? No, oh, it's a keyboard chord. Let's see, runtime app. Where I wanna be, gotta do the same thing. So let's see. So same thing, we want to make sure we do this after we do the project. So probably like right here, I guess. And then we do want to call terminate. I don't think, if we don't call terminate, I don't think it's really going to be like a huge issue. It is reference counted since it's a shared pointer, so, but I mean, you still want to be as explicit as possible though. So AI service, terminate. Okay, so I think that's fine. Again, my server app has nothing to do with the AI service at the moment, so I can go ahead and leave it alone. So I think that's fine. I think the on terminate and on init are good. But let me just go ahead and make sure these compile, and I'm gonna start thinking about these next ones. So these should be done, these two, right? So I believe on update's already pretty much done. Like I think I already coded it. I might need to reread it real quick, but yeah, I think it's fine. I'll definitely have to write these really quick for changing the state, do these all in one chunk. But the nice thing is that since this whole system has already been like pretty well defined, like we don't need to kind of get into the weeds about like how to define these things. We can just look it up and it should be done. So I have a feeling this is going to go faster. Actually, you know what? Famous last words, right? Alright, I'm gonna let it compile. I'm gonna go walk around really quick. I'll give it like 2 minutes, I guess. Dang, I guess it's gonna be more than 2 minutes, huh? Probably really having some issues right now. Oh, here we go. Yeah, I guess the code that I changed is probably some stuff that was kind of high level in the include chains. So yeah, maybe I should take a look at that. Okay. Well, it compiles. I mean, I think that's all I was gonna check for this. But since I'm here, I might as well show you guys what I meant by like what I did in the last commit. So if I go into my testing, basically previously this line looked like this. It said AI message type, new message type is equal to AI message type. I think this is what it looked like last time. And of course this doesn't compile anymore because I changed it. So instead of AI message type, I just hated how this looked. So I changed it to just straight up message type. And I think that just looks a lot better and a lot cleaner. And also like it's not specific to AI, so I mean why, right? The inspiration that I got for this system was from a book. I always link it in the chat. I'm not in the chat, sorry, the gotta stop saying sorry, it's such a habit. I link it in the YouTube, so if you're watching this on YouTube, you should be able to see the link to the book that I used to help me write this code. And yeah, in their code they use a messaging system, and I really love it. So that's kind of where this stemmed from. But yeah, it's not particularly for AI, so yeah, I think this looks a lot better. Okay, so yeah, we did the init, so now we're just gonna do everything else, right? So let's go ahead and take a look. Look at some real code. AIService. So on update, right? Ensure a valid. So yeah, ensure a valid scene is active. Yeah. I don't know why I necessarily need to have it as like a raw pointer though. Like, you just get the ref. I guess I'm just being like pedantic here, but I don't know, maybe there was a reason I used a raw pointer. I don't know. No, it's the same exact thing, so I don't know. So that there's a scene, yep, because if there's no scene, we're running this AI service on update. Yeah, like what are you doing, right? So run on update for all active AI components with that include global and current state, right? So we want to run through all of the entities that contain an AI state component, get each entity, and then we're going to go ahead and present it as an internal. So this is an entity, which is the backend ECI system that I use, and then my wrapper around the entity system is ECS entity, right? So we get that, and then of course we assert, right? And then ECS AI state component, so we get the components that is relevant for this function, and now we do the actual work. So all this was just prep to make sure that we have like all of the data available. So we get the scene, we get each entity, and now for each individual one, we just want to call on update for the global state and then the current state. And that way, like, global state can like influence current state going down this way, right? I think that makes most sense. And then yeah, so I believe I've already gone through the whole deal of making sure that this type function is correct. Like this void uint64 float, like this type of script is the ones that we attach in the UI, so we should be fine. Yep, provide time step. Yep. On update. Yep. Handle delayed message. Okay, so this is good. And then handle delayed message. Yeah, so then we need to do this, which is not handled yet, but we'll get there. But yeah, I think on update is good. I think this does everything I needed to do. And again, if you're confused on like what I'm like comparing this against, like I have a chart available that you can like click on and like read through, and it explains like what each function is supposed to do. So let's see. Change global state. Okay, so this one I didn't finish because I didn't have all of the assets set up and everything, but now that I do, I can do this. So first thing is ensure a valid scene is active. That's, I guess, I don't know. Ref to the active scene. Oh, and the other thing too, I gotta make sure that I'm calling on update before I leave here. I believe I am. Let me just check. AI service. What is that? That's a definition of it. Server testing, I have like a duplicate. Sure. Runtime app. Yeah, here we go, I think. Wait, editor testing, engine, runtime testing, server testing. Wait, do I not call it? I could have swore I do. Hold on. Wait. Let me just find it. Let me see if I do AI service on update. Oh no, I did that. AI service on update with an open. Yeah, here we go. No, I do call it. I don't know why it shows up. It doesn't show up in the Visual Studio thing, but yeah, I am calling it. This viewport panel exists inside of the editor app. So yeah, I'm calling on update here, and I saw it in passing that I am calling it in the runtime app as well. So this is already hooked up, so I don't have to worry about that. And oh my, I really looked through everything, didn't it? So yeah, on update's hooked up and everything, so it's fine. So yeah, let's go check change global state. So this one, by the way, this is like a lifetime function, so this gets called every frame, right? And then these get called, you know, to like initialize like the static resources in here. Here we're starting to get into like the external API situation. So these are the ones that I would call in my scripts to like change a state for a particular entity, right? So you provide an entity ID, you provide like a new state, and then it would change the global state, and then you can do the same thing with current state. So this code's going to look pretty similar. And then actually this code here is going to look pretty similar to the other ones too, because you're still doing essentially the same thing, except we're just reverting between the previous state to the current state. But other than that, it's the exact same code. So these three functions should read pretty much the same. So yeah, ensure a valid scene. Yep, that's good. And a valid entity is provided, so we get the entity from the thing, and then we just assert to each one of these are here, right? Because that would suck if they don't exist. We want to know immediately. Apparently we don't know what an asset service is. Let's fix that. Assets. Asset service. Okay, do you know now? Okay, but now it's like, what are you doing? Oh, because I didn't provide a handle, right? Handle will be... Wait, AI state. Maybe I'm confusing myself. Get AI state. New AI state. Wait, ensure new AI state. New AI state. Oh, there we go. Confusing myself. Okay, yeah. Okay, so okay, change global state, right? Provide entity, provide new AI state, right? So I'm just making sure that AI state is valid that we're providing to this function, right? Then we assert that it's valid, and then we retrieve the component from here, and then I should also put an assert here just in case. So we're going to put an assert that's, well, what happens if it doesn't have it? I think it just asserts here, and then I'll just know here. I can like back up in the call stack and check here. So that's fine. But I don't need to assert with that one. And get components. AI components to be modified. This is a reference, not a const reference, so we can modify it. Call on exit state for active global AI state. What is that? I guess I just copy and paste the code. So yeah, no. Oh wait, no. This is on exit state. No, you definitely do want to call this. So yeah, this is assuming that there is a current global state. So if there is a global state, and that global state has a how do you say, has an on exit state script, then we'll go ahead and call this. And also, by the way, if anyone's confused about like this Boolean thing with this like double and, because you're like, wait, if this doesn't exist and I call this, is this gonna throw an error? These double ampersands, essentially, they're like, I forget the technical name for them, but they're essentially like, they're kind of like short circuit ands. So what that means is it will check this first part, this left operand, right, of this and statement, and be like, okay, is it true or is it false? Oh, it's true. Cool. Then we're gonna go ahead and continue over here because we need to check if they're both true, right? But if this is false, it already knows that this is false, so that means no matter what I put past here is also going to be false, so it can just early out right here. If you just put, I believe, just a single and that might be a bitwise operator. I forget how to like specify like the one for like not doing that, but if you do this, it will early out, and you don't have to worry about this getting called and null pointer dereference. So that's why this code works, if anyone's wondering. So yeah, we call on exit state, and then we switch to the new global state. That's pretty easy. So we're just gonna take AI components dot global state handle. We're going to change that to new handle. So that's going to be a new AI state. Maybe I should rename this to handle. Just for the clarity. And then I'll go ahead and do handle here as well. Let's do a handle here too. And I think the ordering of this is more like this. Again, just being pedantic, I guess. I don't know. Handle. Okay. So we set the handle, and then we do... Now we want to set the actual reference. And how do we set the reference? We get the reference from the asset system, of course. Assets, asset service gets AI states. And then we're going to use this new AI state handle. And then should I assert that it's valid? I mean, probably. You don't want to be assigning invalid references at runtime. That'd be weird. No, but I already checked that here. So I think we're fine. Wait, what am I doing? Just put the new state then. I already have it. Okay. And then this is going to be pretty identical code to this next part. Pretty identical code to that, right? So just instead of calling on exit, we're going to call on enter. And we're still calling it on the same like the same data, right? Because we just switched it. So now this should be pointing to the new state. So we're just going to call enter on the new state. And I believe that's it for these. Let me just double check to make sure I didn't I don't think I forgot anything. I think it should be fine, but make sure store current state as the AI component's previous states. That's only relevant for the current states. Call exit. Set AI component to the new component and then call on enter state. Yeah, so I think we're good. And then I think, so I gotta remember for this one that I need to go ahead and store the previous state whenever I do this, but and then here I probably should erase that. But whatever, I guess that's a little bug. We'll leave that in there. And then revert previous state, pretty similar, but I'm gonna have one little extra step in there. So I think that's fine. Yeah, cool. So this is going to be pretty similar. So I'll go ahead and put this together piece by piece. The first thing, this is one, okay, well this one's gonna be different. So store current state as the previous state. So regardless of what we're doing, this is gonna be, this needs to happen. So change current states. We're gonna say, okay, well we need the AI component first. So we need to do this first part of like retrieving everything. That doesn't change at all. But this next part, now we're gonna do basically this, but not with the current, not with the global state. So we're gonna do this with the current state. Yeah, actually I can just, there we go. Current state handle. And this time we're gonna set, oh no, wait. We want the previous state. We want to set this to the AI component dot AI components, how do you say, current states. Then you want the current states reference. There we go. So basically this will just store the current state into the previous state so that it can be reverted at whatever time you need, right? And then I believe after this it should be the same code essentially. So call on exit state for the current AI state, so that remains the same. The only difference is we're doing it with the current state instead of the global state. So let's go ahead and get it global, make sure I'm not messing with anything funny. All right. We're gonna go ahead and switch the state, which seems fine. So we'll just go ahead and do this. And below is just change it. We already asserted the new state is valid, so again, we don't have to do anything crazy. Maybe I'll call this a new state reference, just to be clear. And I'll go up here and change this to new state ref as well. And then make sure I don't leave that in there. Current state is equal to the new provided state, and the last thing is we're going to call on enter for the next state. Find global, set it to current. And I think that pretty much does it. So now basically we can modify the global state, and then we can modify the current state. And then the current state will blip the previous state, or we'll save it, so we can be reverted to at any point. Let me just read this code real quick, just make sure I didn't throw in any silly bugs, as I do sometimes. Alright, state reference on enter state for the current state. On exit state before I swapped out the state, and then I set it with the new current state and the new state's handle. Yeah. Again, I know I'm being pedantic, but I think I'll thank myself later when I'm reading this code again, and I'll be like, oh, makes sense. This is the AI state reference, and this is the AI state handle, right? Very clear. Let's see. Revert to, sorry, I'm saying sorry. My bad. I'm just, right now, I'm just thinking of, what I want to do next. Again, let me make sure that this is fine. Store current. Yeah. So the next one, previous. The only difference, yeah, so we just want to call an exit, set the current state to previous, colon, and the only difference here is for the revert, it's just we want to clear the previous AI state reference. Like clear the previous, whatever the current previous is, we want to clear it, set it to null. So if we try to do it again, it's gonna be like, what are you doing? You're trying to double up? Like, why? Why are you trying to revert twice in a row? I mean, I suppose you could. It's probably not an error state, but it's still kind of weird. So, okay. Again, like the other ones, first part doesn't change. We still always got to get this AI component. Oh, some of these comments are a bit invalid. Scene reference when calling AI services. Change current state. Could not update invalid entity. Maybe I just won't make this super specific. I'm gonna say mouse. I gotta fix my mouse or buy a new one. Inside AI service. Because this is an assert, so it'll stop here. So invalid scene inside here. Invalid scene inside AI service. I guess I can leave this here. That's fine. Obtained inside AI service. I guess my music stopped. Hold on. Let's see. Ooh. Kind of thumping. Just changing my music real quick. See something good. It's a bit too quiet. I need something to get me going, you know? I guess this one's always good. Real quick, use the restroom. Coffee is doing its thing. So, BRB 2 minutes. 3 minutes. There. Air is loud, man. Where's the thumping? There we go. Provided AIService. Alright, just doing a little housekeeping real quick. So, AIService. Doesn't matter. Put a period there. Okay. Okay, so I think that's good. Let's go ahead and get this previous state thing going. Okay, so yeah, we don't need to do this anymore for this one, since we're just using the... Oh, wait a second. Maybe... Not this one, but we might need to assert that the previous state is valid. Actually, I don't know. So okay, let me open up something real quick and I'll kind of show you what I'm thinking. Let's try paint. Let's try that. Okay. Kind of bright, isn't it? Let's do where is the color values? There it is. Okay. Yes, less hurting my eyes. Good. So basically, if you have like a oh, let me make sure it's light so you can see. So if I have like my current state, right? Go and zoom in a little bit. I have my current state, and then I have my previous state, right? Okay. So if I how do you say? There's a few different cases that can occur. So first is the current state could be equal to could be null, and the previous state could be null, right? So if you revert to the previous state, essentially you're going from and let me see if I can find a arrow. Yeah, you're going from the okay, paint on that. What is that? Maybe it's in lines and splines and whatnot. Okay, I guess now maybe I'll just make an arrow. So we're going from previous state back to current state, right? So if we do that, if the current state is null, that's fine, I suppose. Like maybe you switched into a null state, you want to revert back to a state that you were in. I'm sure that's fine. However, the thing I'm worried about is when you have a previous state that is null, right? So if you do have like a current previous state, right? And then you revert that previous state, we're going to set this previous state to null, right? Because there's no other previous state, right? Like, right. But if the previous state currently is null, what do we do? Right? Like, should I just let it fall through and this just set the current state to null, or should I like throw a warning or something? I suppose in some contexts that might actually be intended functionality, like maybe. But then why wouldn't you just set it to null instead of just reverting it? It seems like such a weird situation to put yourself into. Like in the case where you like intentionally want to just set it back to the previous state, right? Like why wouldn't you just set it to null then? Like if you know you're setting it to null. And actually, now that I say that out loud, that actually brings up a good point about like this section too, because I'm asserting that this state is valid, but there might be a case where the state is not valid. I think that's fine. Like you might want to just change the global state to like nothing. And then what would you do? Just provide like, you know, nothing. Like, right? Like, No, actually, because I'm thinking about how I would do that in my scripts, and I think that would look weird. Like I think I would have to like write like a null type into the scripts, right, for these states, right? And I don't think I want to do that. I think I might want like an explicit API for like setting it to null. So I might have like a explicit like function that I'll have for setting it to null. So you know what? I'm gonna leave this how it is. Yeah. So if you do want to set the current state to null, then just set it to null, you know? You wouldn't want to use previous state to do that. I mean, you could, I guess, like that's like theoretically feasible, but like I think in my API, I think I'm gonna enforce that. Maybe later when I'm making a game, I'll change my mind, but I think for now I'm just gonna go with that. So basically, with that said, I'm gonna go ahead and get rid of this. I'm not gonna assert. I think what I'm gonna do is actually wait, should I assert or should I just put a warning? So let me hold on. Let me move this down a bit. I'm gonna say ensure previous state is valid. There we go. And then we're going to do AI component. I could do this, or I could just get the handle actually. That'd probably be easier. Let me think about it. I'm gonna say previous AI states. Well, no, we don't need to. I don't need to define it like this because it's already available for myself. Like I have the ref. So instead of this, I'm gonna say if AI component dot previous state handle is equal to assets empty handle. If it is an invalid state, then we're just going to go ahead and return. And I'm just going to put a warning saying could not revert to previous state when exists. There we go. Yeah, because I could see some game designer like just accidentally doing that, and then you might just want to know that you did that, and then maybe just be pointed to the correct API like, hey, you should if you mean to just set it to null, just set it to null. Don't bother like reverting it to like something that you know is empty. Kind of weird. Okay, so I think that's handled. So now we can just go ahead and handle the logic. So call on exit state for the current AI state. So that's easy. We pretty much already do that here. And then this is going to be basically this. No, basically this. But kind of reversed, I guess. So instead of, yeah, so this is going to be the current state handle. And then it's going to be the current state reference. And this one's going to be the previous state reference. And this is going to be the previous state handle. Okay, so yeah, we call on exit for the current state, and then we call change state to revert to the previous state. So now the current state is equal to the previous state, and we call enter on the new current state. So that doesn't change. Yeah, this code is like verbatim. And then clear previous states. Yeah, so Now, right, we want this again, but this time we're just going to go ahead and set this to assets empty handle, and we want to set this to null pointer. There we go. Or maybe I just do reset. I don't know. Wonder if these short pointers have an overloaded. They do have an overloaded equality operator. Okay, so I think I don't have to do reset. I can just set equal null pointer and it's fine. Oh, short pointers. Okay, let me make sure this makes sense. So I get this, get the scene, get the relevant AI component, make sure the previous state is valid. Yeah. And if not, we just exit and don't do anything, right? Call and exit for the current state, swap states, call and enter for the current state, and then clear the previous state. So now if you try to do it again, it'll just be like, hey, what you doing? Or it'll just yell at you like this. Okay, I think that's these first three done. That's good. Yeah, and really it's just these last three. So that's cool. Send AI message, handle AI message, and then handle delayed message. Okay. So for this AI message, right? Oh yeah, I was gonna change this name. I never actually bothered changing this name. I think it's because if I switch it to message, I think there's some weird thing with like Microsoft's, like they think they took the message name. So I think I need to leave this as an AI message, which is annoying, but whatever. I'm just wondering like which one I want to start with. Which one makes sense? If I do handle delayed messages, you know, this is going to be the most complicated algorithm, I think. I'll leave this one for last. And really, it's just like a layer on top of just doing these two, so. This will be the main first API, so I'll just go ahead and start with this. So, first thing I'm going to check if message delay is greater than 0. Okay. Yeah, if it's greater than 0, then we want to go ahead and put it into the delay buffer. So literally all we have to do, I believe, is just do AI context dot all messages type. Oh, also maybe I should do AG assert it's AI context just in case you try to like call this without it being valid. Right? Message, not message types. Message queue. And the message queue again, I think is that's a map, right? So you want to do insert or assign. The key is the time. Oh, I didn't think about that. Actually, there are some potential bugs with this now that I'm thinking about it. So yeah. Okay. Yeah. I mean, yeah. Okay, so let me tell you what I'm thinking, so you can understand what I'm sighing about or whatever. So the first thing is like, okay, this message queue is a map, right? And it's mapping a float to an AI message, right? So floating point like comparisons are very like finicky, right? Because like the way that floating points are stored in memory is very the IEEE standard. That, or is it IEEE? I don't know who's the body that defined it. You know, we're talking about networking code. But anyways, the standard that defines the floats, it's fairly imprecise, and I think that's on purpose, right? Which is good in this case, because that means if I add a message and then I add like two messages at the same time that have like the same like delay time, then theoretically they shouldn't overlap, as in like one shouldn't like overlap the other, or like, you know. So that means both messages should still be handled, essentially. But the thing is, that's not guaranteed. There could be a possibility where there's just the data representation of the float in memory is just exactly the same, and then you try to insert it and it just overwrites the other message. And since that is a possibility, you could potentially overwrite a message that's already in the queue, right? Especially if you're sending like a lot of AI messages all at once, like that possibly could happen. Again, very, 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 very unlikely, but I just don't like it even being like potentially a thing. We are sorting it by floats. So yeah, this is making me rethink this map data structure. I think I can still get like this functionality out of this, but using like a different data structure. So my main requirements for this is that I need the data structure to automatically sort the messages in the queue, right? I want the messages to not overlap. So it is possible to have two messages that are equivalent, and in that case, like have equivalent delay time, and in that case, they just like you just put one behind the other. It doesn't really matter what order. I don't really care. And I want it to be somewhat performant, you know. When looping through the queue, right? So automatic. Let's take a peruse through the standard library data structures. Maybe something will pop out. I could like literally use a queue, but I kind of don't want to. To be honest with you. Let's do CPP reference. Where's the map? Here it is, containers. So we have a vector. I could totally use a vector and then maybe manage it outside of, but I would like a data structure that I can just kind of like throw things in and I can just forget about it, you know? I could use an unordered set and then use the AI message as like the key, and then maybe just provide like a hashing function override, and then just say that when you do a comparison for the hash, you use the how do you say, you use the time for the comparison, but then I think we would just be in the exact same boat we are right now, and that's kind of annoying. Yeah, I'm not too keen on just like writing new data structures from scratch right now. Because I kind of see a way of getting through this with if I write my own, but I don't want to. Automatically sorts, huh? Doesn't overlap. One thing I could do is just keep it the way it is, like the way I have it as an unordered map, and then just handle the case where it's unsuccessful. So if it is unsuccessful, then we'll maybe like increment the time by like a certain constant, and then try again, and then just keep doing that until it inserts inside of a while loop. I could do that, and then like hopefully the cases where that happens is fairly minimal. So it kind of has the behavior of like a I forget what they call, but it's like a certain type of hash table where basically like a normal hash table, you'd have like keys that map to specific slots inside of the data structure, and then each slot is basically just a linked list. And then the linked list is just a linked list. So it's like a linked list of the values that all collided at that location, right? And then they're sorted based on the actual particular key, because of course the key is still unique, but the hashing function that placed it into the data structure ended up colliding. But there's another hash table where instead of creating a linked list, you just how do you say? You just realize that there was a collision, and then you just increment the position until you find a position inside the hash table that is actually available, and you just store it there, and then the whole hash table kind of just runs like that. So maybe something like that. And actually I think those are actually fairly performance. I don't see why it wouldn't work in this case. So I might take like a similar approach to this. Yeah, you know what, I think that's the best idea I have at the moment, so I'm just gonna go ahead and do that. Wow, this is loud, holy crap. Turn this down. Yeah, I'm gonna go ahead and do that. So I'm just gonna handle the case where it doesn't work. So let's go ahead and just do like a standard insert. I'm not gonna do an insert or assign. And let me just make sure. Just take a look. And it's unordered. No. Map. std map dot insert. So take a look at this. See how this works. Oh yeah, you can provide an allocator. I always forget about that. I gotta learn more about that at some point. Okay, so we do have the iterator and the bool, so that's cool. And then if you provide the type, so you have to provide it as like a single, how do you say? You probably have to provide the key and the handle as one like object. I could probably just use initializer list. That'd be good enough. But yeah, it looks like the insert can fail, and then if it fails, it just returns a boolean whether it did fail. So I might just use a regular insert, and then if it does fail, I'll kind of take the approach of just using a while loop and incrementing the time by a certain very small factor until it can be placed inside of the how do you say? It can be placed inside of the data structure. And hopefully I won't have to do this too much. Let me read this really quick. Insert overload is equivalent to in place and only participates in the overload resolution if... Okay, parameters, iterator, sure. Okay, 1 through 3. A pair consisting of an iterator to the inserted element and a bool. Oh, actually, wait, let me look at parameters really quick. Insert value, overload is equivalent to in place and only participation. Okay, so I think that's what I said. Like what I said this was, like I think this is fine. Yeah, and then the bool is set to true if and only if the insertion took place. So I'm assuming if the insertion did not take place, that means there was a like a collision, like a full collision. Then you could not insert it, so it just returns a bool saying false. So let's see. So yeah, I think this is the intended behavior I want. So insert, and then we're going to go ahead and do initialize a list, and then the first part is going to be the message delay. And then the second part is going to be, you know what, maybe up here, just go ahead and create an AI message on the stack. So we'll do an AI message. Go ahead and do a new message. Let's go ahead and initialize like this, why not? I think message type, sender, receiver, delay. So message type, sender entity, receiver entity, and then message delay. There we go. Perfect. All right. So this is gonna make, so if I do this, it's gonna make a copy of it, I believe. Yeah, because this is a fairly big dash, not huge, but not the worst thing ever though. Okay, so let's get the insert. Same thing as before. We're gonna do an auto, and then we're gonna get the iterator, and then the success. Okay, and then we're gonna say if not success, then we're gonna just fall into a while loop. I could do an SD bind to this one, I suppose, and just keep doing the loop here. Now the loop there, and I don't have to keep doing that. Let me define like a const, static const texture. Do I need to do both? I don't know. And do a do not build, please. We'll call this K. Increments message time. Maybe by a very small amount, but it'll be like a nice constant amount. So I'm gonna do 0.000000025f. Like that. Not define it as a float. There we go. That's a pretty small. I just wanted to be like significantly small enough where it's like not much of a change, but like significant enough where it will change the value. So yeah, I think that's a fine value. And then now we're just gonna do some sort of while loop here. I think I might define it. Let's see. I might have to do like a bind or something. I think it's yeah, this is weird. I don't want to do this, I gotta think. Again, basically, I'm just trying to get this to while loop. So let me just start defining the while loop really quick. So while, and I'll do a bool on the outside for success, or I'll say insertion success. And I'll say false initially. And then I'll say while not insertion success. So like while we're still unsuccessful, we're gonna go ahead and keep looping through. And then I need to find some way to like bind this return value to here. It's a bit annoying that they return it both like this. I could ask ChatGPT, I guess. I mean, I've done this before, but I don't know. Maybe if I just call it insertion instead, it's probably gonna like yell at me a bit. I'll be like, why are you redefining it? Insertion success. Okay, well, this is fine. I'll just put success. And then I'll say insertion success. Maybe the compiler will figure it out. It's not like the craziest code. Okay, and then okay, yeah. So this is copied. So I can probably just modify this if I want to. So I don't actually need to modify this too much. I don't think. I think this matches other requirements. Let me actually describe what I'm doing here. Insert message into delay queue. If unsuccessful, increment delay time and retry until successful. So in the case where it is successful, we go in success, insertion success is equal to success, and then if it is successful, we just go ahead and exit. But if it's not successful, we want to make sure that we want to make sure that we increment message delay. Let's equals constant increment message time. There we go. So we keep incrementing it, and then this will change each time, and then it'll go ahead and keep modifying it until it actually works. And then if I increment it once, but it already worked, then it's fine. I don't have to worry about it again. So this is the case where the message delay is greater than or equal to 0, right? Else, and I'm just gonna say check if the message should be handled immediately or placed into delay queue. And I'm gonna say here just handle message. This one's the easiest one. We just do send AI message. No, handle AI message. Handle AI message. And then we're just gonna provide the new message. And then we'll go ahead and exit. And actually, okay, so in this case, I can't provide like an R value, because if I provide an R value and do an SD move on this, if I try and reinsert it again, it's going to be like invalid memory, and then this is not going to work. But in this case, I actually could take an R value. So I'm going to specify an R value here. And then what I'm going to do is I'm just going to do an SD move. It might be an over optimization thing right now, but I just want to make sure that this memory gets like transplanted directly into here, so I don't have to keep making copies of everything. Here, there's no other way to get around it, really. I'm gonna have to make a copy, so. But, you know, if I can get the performance gains, I might as well. Yeah, I think we're good. I think we're good. And then here, we just handle the message. So this one is essentially going to be something like this, where we just we call on message for recipients. What am I typing again? I don't know. We need to edit it. We're gonna need to edit this though. But yeah, this is literally all I have to do. Just call the message, but we're going to use the onMessage function instead of like this one, right? And then the other thing is I need to go ahead and get the actual receiver. So this is actually an interesting question. When I make this, handle AI message. The thing that I'm wondering right now is whether I should, how do you say? Whether, like when I'm calling the function in the scripts, should I make like an AI message struct and then just provide the struct here? Or should I like just flatly like send out like this, like each individual member? I think I'm gonna err on sending out each member. I think it's a bit clearer in the receiving function, like what's happening. So yeah, I'm just gonna go ahead and do that actually. So this might actually end up being a new type, but it's gonna look something like this. So void, do we need to handle like a success? I don't think I need any information from this message. It just handles it and goes about its day. So we want a uint 32, and then we want a uint 64, another uint 64, and then we want to float. It's be hilarious. This actually exists. Okay, no, it does not exist. Okay, good. I figured it wouldn't, but you know. So yeah, let's get this to work. So before this, again, I'm going to need to go ahead and get I believe the recipient. So we're going to get the scene, and we're going to get the entity, and we need the AI component of the recipient. So sure, valid scene, valid entity. This is entity ID, but we're not going to use that. We're going to use the message. So we're going to use message to handle what did I call it that? Handle. Anyways, receiver entity, and then name this to. Oh, there's only one. No, do receiver entity be clear. Okay, so we just make sure the receiver entity is valid, right? And then get AI component to be modified. So this stems from the receiver, and then who's on message function needs to be called. There we go. And it's gonna be again, just to be clear, receiver AI component. For the receiver entity, get its state components, we get the receiver AI component. There we go. So now that we have the AI component for the receiver, we can go ahead and call the on message for it. So first things first, we want to do the receiver AI component, and we want to do oh, that's a good question, actually. Do I want to do it on both the global state, or do I just want to handle it both the global state and the current state, or do I just want to handle it in the current state? I might want to do both, actually. Yeah, because I might add some logic into either, and I want both of them to receive it and handle it. So for recipients, global state, and then let me just put a comment saying for the current. I'm not going to copy it yet since I'm going to change this a lot, but there we go. So let's see. Let's go ahead and do the global first, and global state reference. Now this time the global state doesn't necessarily need to be valid. And then again, yeah, that's fine. So I think this will just fall through. So if it's not valid, it's just going to move on. So first it checks if the global state is valid, then it'll check if receiver AI component current state reference on global, and then we want to check on the message on AI message, which again, maybe I should just do on message. We're actually making a lot of progress with this. It might not seem like it, but we're actually almost done. This is really cool. Okay, so on message. Cool. So now that we've verified the global state has it on message, we need to call it, right? And with this monstrosity of a function, I think we can do it. Give me another 2, maybe 3 minutes. I'm gonna use the restroom again. Coffee is going crazy. Yeah, I might take like a 4-minute break actually. I'll be back. Ooh, alright. That was less than 4 minutes or something like that. Let's keep going. Okay, so I first provide the function, and then I provide everything else, right? So, let's see. First major thing is I need to get this working, so let's go over here. And the first thing is I need to make this a thing, so this is going to be fun. Void uint32, uint64, uint64, and floats. And I do expect this to throw a few like errors and whatnot, because adding new ones of these usually gets kind of complicated, but I have some pretty good asserts for it, so the engine should yell at me when I mess it up. But yeah. Okay, so these are just wrapped variables, so that's fine. Now we want a wrapped func, so let's go ahead and add one for this actual definition. So uint32, so uint64, uint64, and then a float. So uint32, uint64, uint64, and a float. Okay, and then wrapped function, we're going to want to add it right after here. Very easy place to add bugs, so let me be careful. So 32, uint64, uint64 float. And then, yeah, that is a mouthful for sure. Yeah, I think I might change this to being like a C-style function pointer at some point, but it works for now, so I'm not gonna argue with it. Underscore T, float, yep. And then this one's gonna be a void uint32, uint. Okay, there we go. So type, this is invalid because we need to add this. The void is still fine. And I believe that's fine. Yeah, what a function. Let's see. So these are wrapped vars, two different things. So these are fine. I can leave them alone. Wrapped var types. I didn't add any new var types. So. Initialize wrap data for var buffer. Yep, nope. I need to update any of this. Okay, here we go. So this one, we're gonna go ahead and update it to void this monstrosity. There we go. There we go. And then same thing here. I just want to do that. Basically identical. Call wrapped void none. Call wrapped. Okay, so here's where we actually add that function. So be like right here. Let's go ahead and just do, if I have void uint64 float, then we're going to change it to a basically the same thing, just uint32 and then another uint64. Okay. And then this doesn't exist, I think. Oh, no, that's fine. Yeah. Void uint32. There we go. Okay, and then we have to provide the actual arguments. So it is going to be a uint32. This is going to be uint64 underscore t argument 2, and then a uint64 underscore t for argument 3. And then this one's going to be called argument 4. and then we just want to pass it straight in. Argument 3, argument 4. And that should be fine. Yep. So yep. U32, 64, 64 floats. Yep. And these are all named correctly. With the correct type. Generic warning. Only function that's that long. These. Okay, and then all the rest of the little defines and whatnot I got. So this one's pretty easy. Just void the ints here. Parameter. Okay, so this one's gonna be a whole new thing. So do this, and then this is gonna be all the parameters. So uint. Where is my autocomplete? Void uints. There we go. And then this one, I'm going to do a 32. And then these are just different like utility functions for different things. So thing is the way that I have to set up like these kind of like dynamic function parameters and whatnot to get it working with C++ is you have to like statically type pretty much everything, right? So if you want to set up scripts, you have to like statically type each of the types like directly in the engine. You can't like do some, I mean, you could do some like template stuff and whatnot. There might be a case for that maybe later with this. Also you could do macros, but I don't like overusing macros. I think, especially since like this code is something that like I'm mostly going to be reading rather than writing to most of the time. I want to make sure that when I come back and I want to read it real quick, it should be like easy to read. The only time I justify using macros is code that's like very, very back end and is like a single layer deep. Like I'm not going to add like nested macros or anything. And it's just like so much work, so much overwhelming work that it's like, why are you not using macros type of deal? But other than that, I don't love using macros because I think it obfuscates the code in ways that are just like, what is going on? Okay, so you went 32, you went 64, you went 64, float. Yep. Oh, that's it. Nice. Okay, cool. So all that to say that like this works now. So now let me just figure out where else I use these. Might be somewhere I forgot to like add. So let's see. AIState editor, no, those are fine. Those are like predefined types. Actually, that's a good point though. Now that I think about it, think real quick. Okay, wait. So script service, this is probably where I need to go check. This is fine. This little scene editor panel thing, because this is like a check I do in the UI, so this wouldn't change. Wrap data, this is where I just modified. So there's two places I want to go. This is the first place I want to go, because this is the way that I sort of like connect the script functions with its counterpart inside of the actual C++ DLL, because in the actual DLL it's literally just provided as like a normal C style function pointer, and I have to use like get proc address, like the Microsoft get proc address to actually get the actual function pointer and then convert it into the wrapped script thing that I have held internally inside of my asset system. So I need to like statically type this here. So let's go ahead and just provide this now. But instead of this, going to do void uint this long ass thing, and then we're going to do wrapped. See if I can find it. Wrapped. Let me type it down more. Uint 32. There it is. Let's go ahead and copy and paste this. There we go. And then this is that one define I showed you up here when we were first starting it. So this is like the raw function pointer version of it. But yeah, you can see it's just defined as essentially just this with void and everything. So let's see if there's anything else I forgot here. This will define as the correct type. Proc address, just a overlap. I mean, this is just variables. Okay, yeah, this looks fine. And then the other thing I wanted to fix was the fact that in here, when I add on a message type script, it shouldn't be doing this. It should be something like this. Yeah, this is the type of function we want to add. I might have to do a little bit of modification in the scripting system, maybe. Actually, no, wait, no, I don't. No, I don't. Never mind. Sorry, I'm kind of just thinking into like different sections of my engine, but I was thinking like, okay, maybe I have to edit some more code to make this to work, but I don't think I actually do, because I already have I have a lot of these like static utility functions here, and I define them in one place so that I can just use these real quick, and then I can get like real quick like a parameter list, and I can use these to like automatically generate like function signatures and whatever else I need, or I need to get a return value real quick. I just provide the func type, and I get the var type back out like that, right? Nice and easy. Okay, so let me get out of here. Again, all of this worked to like suffice to say that now this exists. And let me go back to what I was doing, wherever I was working. Here. Okay, cool. So now see, this is a thing. And now we just need to provide the actual correct values and whatnot. So we need the correct component. And then we need to get the correct reference, which is not current, it's global this time. And we're not calling an on enter state, we're calling a on message. And we already checked that the message was valid here. And now we just need to figure out what we're sending. So the first one is a uint32. That one is the actual message enum. So that's going to be message to handle dot message type. Yep. Message to handle. I believe it's sender first, and then message to handle receiver next. And then last one is the message to handle. Let me just be crystal clear about that though. Crystal clear. It is the sender first, then the receiver. Yeah. Sender, then receiver. Delay. Okay. I think that's it. Yeah, that's literally it. So now, all we have to do is just take the global and call current now. Actually, we'll do capital global, and then we'll do capital current, and then this is just a lowercase. And I think other than that, global current, yeah, current. Call it with the current values. Values don't change. We're still calling it the same message. Yeah, I think that's it. So if we call handle message in this case, we don't add it to any data structure, so we just handle it immediately and then we exit. So like that, we're good. In the case of like receiving a message when we do this part, we need to make sure that we remove the message from the data structure. So that's the last thing. But let me take a look. Let me see where I'm at, what time I'm at too. 1 hour 57. I might be able to finish this right now. Let me take a look at the diagram too. So yeah, we pretty much finished everything in here except for handle delay messages. And here, all we have to do is just get the message queue, decrement all the messages based on the time step, right? And then if the delayed message time is less than or equal to 0, call the on message. So pretty simple. I think so. There might be some like weird stipulations with this one, but we'll handle it. Okay. So I'm just gonna do a naive approach first, and then if I need to fix it, I'll come back on it. So check all delayed messages in current AI context. So we're gonna do for AI context. So pointer message queue. Okay. So I believe it is an iterable in the standard. Then for each one we do auto. Do I want a reference? Yeah, I think so, because the message queue is not a fully trivial amount of data. So the delay time is trivial, but the message is not trivial. Okay. And then decrement each message's delay using the time step, and then check if each message should be handled. Okay. So the thing is, we will be doing CRUD operations, right? For the different, how do you say? Oh, wait a second. Hold on. I just thought of an issue. If we are storing these things as an unordered map, right, and the float is the key, the float is imprecise, so it might not... Okay. So how do we uniquely identify it? If floats are imprecise. That's an issue. Yeah, that is an issue. Because each insertion operation needs to be done, insertion and removal operation needs to be done, how do you say? In like a specific way. That's interesting. I'm gonna take a break real quick and I'm just gonna like think for a little bit. I'll be right back. Give me like 3 minutes. Okay, I'm back. I asked ChatGPT about my situation. It told me to use like a very specific data structure, like a min heap, I guess. I kind of have an idea what that is already, but I think I want to take some time and like really look at it, because sometimes ChatGPT it's kind of bad with like context specific information or like situations. So but I will look into it. So I think I will stop the stream right now for the time being. Let me go ahead and move this back. And let me get my project back as well. Let me put this over here. Close this. All right. Well, we're about, I would say we're about 95% done with this part. This last part, I'm just trying to make sure that the data structure that I use for this handles the use cases that I need to effectively, which again, the data structure needs to be easily sorted. So insertions need to sort the structures or messages into the data structure really easily. I need to be able to loop through the data structure pretty fast, so it needs to have a really fast iteration time. And I need to be able to easily remove items. Yeah, I need to be able to easily remove items in the data structure. And I realized that removing the objects here using this delay time is super imprecise because we're using the float as the key. And if we're using the float as the key, we might like provide a time that we want and as a key to go ahead and remove an item over here, but it might not actually like evaluate to the correct value. Like that's a possibility. I don't want that being a possibility. So I think what I need is some type of more flat data structure where I don't necessarily use the delay time as a key, because I don't need to query it at runtime. That's not, we don't need to like, how do I say, yeah, like query items based on delay time key. That's not a requirement. That's kind of like a big reason why you use a set in order to map. So since I'm not doing that, this probably isn't the right use case then. So yeah, I'm gonna think about that, and I think next stream, when I start up, I'm gonna finish this real quick and then just test it, and then we can move on to just setting this up with the scripting system and then like fully testing it, right? But again, I think we're getting pretty close. Next stream, I'm closing the stream pretty early, but hopefully next stream we can get through this real quick, because I'll have looked through the data structure pretty well and I'll have an idea on how I want it to work. So let me just do a few housekeeping things, and then I'll go ahead and end the stream. So first thing, I'm gonna go ahead and push the code. I'm gonna just commit it. I'll push it later. Let's go ahead and see. Oh, let me compile it really quick. Let's see. But yeah, we're getting pretty close with this system. I believe once it's done, we'll go ahead and write the Pong code. What I envision from the Pong code is essentially, we're just going to be using the system to make, we're just going to set up the system, and then in the onUpdate function, I'm going to add some logic for basically having the paddle, like, what is it called? Follow the ball, right? In the Y plane, right? And then I might add different states for just how the paddle pursues the ball. So like maybe it will speed up, in a certain state, or maybe in another state it won't speed up, or it'll do like a certain, like different logic depending on, right? It might overshoot in certain cases, and then I guess the initial like prototype for it it'll probably be like really good at the game, and then I'll start having to make it like more dumb to make it more fun, right? And then I guess like the more I add like kind of like dumbness to the AI, the more it'll feel like a real opponent, I guess. But yeah, that's currently my idea. So it'll be pretty simple, and then I might still use those like on enter and on exit states to maybe like play some noises, like when the AI decides to like I don't know, like do something specific. That'd be kind of cool. I don't know. It's not really necessary for Pong, but I think it'd be kind of cool to just have like a little effect going on or something when it changes states and whatnot. But I don't know. We'll see. Again, it's Pong. I mostly just want to keep it simple. I want to just get a game done, but you know, still have fun with it, right? All right, so looks fine. Let me try to run it. Looks good to me. Yeah, looks good to me. No compilation issues, right? So yeah, let me go ahead and push the code really quick. Let's see. Name. Let's see. Okay. And Init / Terminate. Invitation to AIService.cp/h and use these functions in editor app.cp. There we go. That's pretty much all I did there. Okay, well, I'll come back to this in a second. Let's see. This is still like the light refactoring. I'll say in there and state manager.cpp. Wrap data. Add another type in wrap data.h. There we go. Yeah, it's the same thing. And script service.cpp. All right, and then I'll just say add implementation for on change states functions inside AIService.cpp. And then start implementation for handling messages in AIService. Okay. And that's pretty descriptive. Let's go up here and then I'll say start adding function stubs. Oh no, function implementation for AIService. Okay, there we go. So let's go and look at the progress board. I don't think I have anything to update yet. We're pretty much almost done with this, like 95% done. So next stream we'll go ahead and finish this. And then we'll go ahead and start on just getting it reflected in the scripting system. Shouldn't be too bad to do that. I don't have that many functions to add. And yeah, once we're done, hopefully that goes back pretty fast and then we can just test the code. But yeah, let me check if there's anything else I gotta do. Let's see. Okay. So we'll go ahead and exit this, end the stream. I'm gonna bring the face really close. So yeah, I might do an extra stream today, but actually no. Actually, I think today I'm gonna go ahead and stop. I'll pick up tomorrow. I think tomorrow I'll do a little bit more streaming than today. So yeah, that's the plan. So yeah, all right. I hope you guys have a good day. I'll see you guys next time. Later.